In this video, we'll learn how to divide polynomials by using long division. So on the screen here, you can see that we have two numbers. We have 2x squared minus 2x minus 60, and that is going to be divided by x plus 5. So if we're going to use the long division strategy, we're going to turn this into a long division problem by setting it up like long division. So we're going to start by writing the x plus 5 here on the outside, and then putting 2x squared minus 2x minus 60 here on the inside. So what we're going to do is we're going to focus on the polynomial on the inside there, and we're going to focus on it one term at a time. And one term at a time, we're essentially going to figure out what we need to do to x plus 5 in order to eliminate those terms. So I'll show you what I mean, as it's easier once you see it to understand what's going on. So the first thing we need to do is we need to take this first term here of 2x squared, and we need to divide it by this x term here. So remember, the coefficient of x is really 1, so 2 over 1 is 2, and then x squared over x, it cancels down to the x. So the first part of our answer here is going to be this 2x value. So that's the first part of our polynomial that's going to result as our answer. And so what we're going to do is we're going to take this 2x and we're going to multiply it by both x and 5. So x times 2x becomes 2x squared, and 5 times 2x becomes a positive 10x. So now what we're going to do is we're going to take the polynomial in red and we're going to subtract the polynomial in blue from it. So you need to be really careful here. So we take 2x squared minus 2x squared, which becomes a 0x squared. Then we take negative 2x minus 10x, which is negative 12x. And then this negative 60, because there's nothing being subtracted from it, just carries down to be negative 60. So now this is our new polynomial to focus on, and we now have a new value to focus on first, which is negative 12x. So you can leave the 0x squared there, or you can say, well, the x squareds are gone, and because I know the x squareds are gone, I don't need to write them in there. So now we're going to focus on negative 12x and eliminating that out of the problem. So we go through that same process we did before. We take negative 12x and we divide it by the 1x that is out here in front. Negative 12 over 1 becomes a negative 12. The x's cancel, so what we're going to multiply x plus 5 by this time is negative 12. So that's the next piece of our answer. So we multiply x by negative 12, which becomes a negative 12x. And then we multiply negative 12 times 5, which becomes a negative 60. So now we're going to repeat that subtraction process. We're going to take the polynomial in purple, and we're going to subtract from it the polynomial in blue. And this is where you do need to be really careful, as it can be pretty tricky. So here we have negative 12x minus negative 12x. I'm just writing it off to the side so we can visualize it a little better with the negatives. Remember, if we utilize keep, change, that becomes negative 12x plus 12x, which becomes 0x. And then we repeat this process. We take negative 60 minus negative 60, which again, keep, change, that becomes plus 0. Notice that everything has now canceled out. So when everything cancels out nicely, we're getting a really nice answer. And here we can see that 2x squared minus 2x minus 60 divided by x plus 5 results in the polynomial 2x minus 12. So that is our final answer. Now truly what this means at the end of the day is that if we take 2x minus 12 and we multiply it by x plus 5, we're going to get 2x squared minus 2x minus 60. So that's really what this means. But here is our answer, and you can see how long division helps us to figure out x plus 5 times what will give us this larger trinomial. So let's try this second example here. So again, I'm going to set this up for long division by taking x minus 1 and then having our x cubed minus x squared minus 2x plus 8 here on the inside. So let's start by focusing in on this first term here, which is x cubed. So I know that my goal is to kind of eliminate that x cubed out by figuring out x times what is going to produce x cubed. So we take x cubed and we divide it by this term here, x. And x cubed over x produces x to the power of 2. So first thing we're going to do is we're going to multiply both x and negative 1 by x squared. So x times the x squared here becomes x cubed. And x squared times a negative 1 becomes negative x squared. So here we're going to use subtraction. So x cubed minus x cubed becomes 0x cubed. And then I'm going to write this one off to the side because there's a lot of negatives. So I have a negative x squared minus a negative x squared. So keep, change, that becomes negative x squared plus x squared, which becomes plus 0x squared. So in one step, I was able to eliminate 2 of those terms, which is kind of interesting. So from here, I can just bring the rest of the problem down. So I still have minus 2x plus 8. So because all of these canceled out, you can erase these zeros out of here if that confuses you to have more writing there, especially when they're canceled out. So our next step here is to now focus on this negative 2x term. So we're going to take negative 2x and divide it by our x here. So we have divided by x. Well, negative 2 over 1 is negative 2. X over x cancels out, so we're just left with negative 2. So we're going to multiply x minus 1 by negative 2. So that's our next term here. So from here we multiply, and we get x times negative 2 is a negative 2x. Negative 1 times negative 2 is a positive 2. So now we're going to subtract. And again, you can make little sketches off to the side if you have a lot of negatives. So we have negative 2x minus a negative 2x. Well, keep, change there tells me that negative 2x plus 2x becomes 0x. So those cancel out. So you can either cancel them because they cancel out or write the 0x there. And then the next part is 8 minus 2, which becomes 6. Now, what you need to notice here is that there's really no way to eliminate this 6. So if we take this 6th term and we divide it by our x here, there is not a good way to eliminate this out because 6 can't be divided by x nicely to produce something like one of these terms that we can multiply by. So if you're left with a number where you can't actually eliminate anymore by multiplying by something that's nice, what you're going to do here is you're actually going to write this as your remainder. So what we've done here is we've divided x cubed minus x squared minus 2x plus 8 by x minus 1. And what we've found as our answer is we have found that we have x squared minus 2. And then we have this remainder, so we're going to write plus a remainder of 6. So notice I have my remainder in my numerator here. And then in my denominator is the polynomial I was dividing by, which is x minus 1. So notice that's the polynomial that I was dividing by in the first place. So when we divide these two polynomials, we end up with x squared minus 2 and then with a remainder of 6 over x minus 1. So third and final example here. You'll notice that we have 2x to the fourth plus 3x cubed plus 5x minus 1 divided by x squared plus 3x plus 2. And before we write this down into polynomial long division, I want you to note that while this first polynomial here is written in standard form, it's missing an exponent in there. So we have to the fourth power, the third power, the first power here, and we're missing an x squared. Now, there doesn't need to be an x squared in the problem unless we're actually dividing. So what's really happening here is we're going to need to add in a plus 0 x squared. Because at some point we're going to need to be able to deal with the fact that there's an x squared term that's going to pop up somewhere. So, as we write this out into our polynomial long division, I'm going to add in any things that are missing. So, any exponents between the highest and the lowest that are missing, I'm going to add in with a 0 as their coefficient. So here we're going to take x squared plus 3x plus 2, and we're going to put inside of that long division symbol 2x to the fourth plus 3x cubed. Notice I'm adding in plus 0x squared, so I account for every single possible exponent of x, plus 5x minus 1. So that's where we are going to start. Now, just like we started before, we look at the first term on the inside and the first term on the outside, and we divide them. So I take 2x to the fourth, and I divide it by 1x squared. 2 over 1 is 2. X to the fourth over x squared, we subtract the exponents, and I get x squared. So I'm going to multiply all three of these by 2x squared. So if I multiply all of these by 2x squared, I end up with 2x squared times x squared, which is 2x to the fourth. 2x squared times 3x, so 2 times 3 is 6, and x times x squared is x to the third. And then I have 2 times 2x squared, which becomes 4x squared. So that's where we start. Now from here, I need to subtract the polynomial in blue from the polynomial in red. So we have 2x to the fourth minus 2x to the fourth. Well, I can already see that that's going to become a 0x to the fourth. Then I have 3x cubed minus 6x cubed, which becomes a negative 3x cubed. And then I have 0x squared minus 4x squared, which becomes a negative 4x squared. So you can see where adding in this zeroed term right here was important because we had to deal with an x squared term in there. So that's why you always have to add in those missing exponents between the highest degree and the lowest degree. Now, from here, we're just going to bring the rest of this problem down. So we now have plus 5x minus 1. And because this is just a 0 out in front here, you can erase it out of the problem now, since you do know for a fact that these cancel out. So we've now accounted for the x to the fourth term. So now we're going to move on to the x to the third term. So we're going to take negative 3x to the third, which is our new first term, and divide it by x squared. So negative 3 over 1 is negative 3. X cubed over x squared, we subtract the exponents, so we get negative 3x. So now we take negative 3x and we multiply it by x squared, 3x, and 2. So negative 3x times x squared becomes a negative 3x to the third. Negative 3x times 3x becomes a negative 9x squared. And negative 3x times 2 becomes a negative 6x. So what we're going to do again here is we're going to subtract that term in blue from the terms in purple. So if you need to write them off to the side to help you with the negatives, that's okay. So we have negative 3x cubed minus negative 3x cubed. Well, keep, change, that becomes 0x cubed. I then have negative 4x squared minus a negative 9x squared. So keep, change, that becomes a positive 5x squared. And then I have 5x minus negative 6x, which keep, change, becomes 11x. And then from here I can bring the negative 1 down still, and there we have our next polynomial. So again, if you don't like the zeros being in there, you can now eliminate that out because these eliminated each other. So from here, we now focus on our new first term, which is a 5x squared. And we're going to divide that by the first term up here, which is x squared. So we put a 1 in front of that bottom one. 5 over 1 is 5, and the x squareds cancel. So our next part is just plus 5. So we're going to multiply the 5 here by all three terms of the x squared, the 3x, and the 2. So 5 times the x squared becomes 5x squared. 5 times the 3x becomes 15x. And 5 times the 2 becomes 10. So from here we now need to subtract what's in blue from what's in red. So 5x squared minus 5x squared I know becomes 0x squared. 11x minus 15x, I can see becomes negative 4x, and negative 1 minus 10 becomes a negative 11. So I can see that the x squared is now eliminated out, and I'm just left with negative 4x minus 11. So I focus on my new first term, and I have negative 4x divided by x squared. And when you reach a point where the degree in the bottom of the fraction is higher than the degree in the top of the fraction, this is your symbol where this right here is our remainder. So that's what you're looking for off on the side. When you get to a point where the number in the bottom, or the exponent in the bottom, is higher than the exponent in the top, you stop at this point and you have your final remainder. So we're going to write our final answer here to our division problem is 2x squared minus 3x plus 5, then with a remainder added on of negative 4x minus 11, all divided by our original polynomial we divided by, which is x squared plus 3x plus 2.